the logic you see, right? Like
Yeah.
let's say x plus y is equal to x plus y plus z plus y, right? And then if we assume x and z are same, then that boils down to twice the distance, right? So which indicates, I think that might be the logic, which indicates that the tortoise has to move equal distance what what head has to move from the start, because we are assuming uh, the first half, basically, which was, I don't know, x in your case or whatever, is equal to the z, right? And because that was the case, that's why it became twice. Now it's twice, right? So I mean, why it is twice? Is it because
well, the twice is because, let's assume in that case, right? So that we know that one of the pointer moves twice as fast as the
right. So what I was thinking, what I was just coming to down, let's say if it moves 5 times or 4 times faster, right? What I was just saying, then will that be equal to like x plus y is equal to 4 times, because x plus y on the other side 4 times. If you see my point, right?
Right.
And if that's equal, then that's just because the fast pointer is moving 4 times faster. That's why it's 4 times x plus y, right? And
right.
If that's the case, then we have already assumed that x is equal to z. And because x is equal to z, or maybe we can do backtracking, because it is moving 4 times faster, so it has to be equal. To make that thing equal, it has to be, means the first part, which is x, has to be equal to z. So that means the slow pointer has to move equal distance what head has to move from the start. Did I confuse you, or?
So I think the x is same as z comes out as a result of our initial assumption that the tortoise moves half as fast as hare. In other words, hare moves twice as fast as tortoise.
Right. So we start from the speed, right? Let's say if hare was moving 3 times faster, right? 3 times. So x plus y is, yeah, you were right, actually. X plus y is equal to 3 times x plus y, because it is understood hare has to move 3 times faster, right? So x plus y of the tortoise is equal to 3 times x plus y of the hare, right? And if that's the case, then that means the formula which we came up, where x plus 2y plus z, means x plus z has to be same. X and z has to be same, right?
Right. And also,
and now because x and z are same, that indicates that we have to move from meeting point same distance what somebody will move from the head, right? And that will give you the meeting point. I mean, correct.
I'm just trying to wrap my head around. So I put in an equation where I say, if the tortoise moves x plus y, then the hare would have moved x plus y plus z plus 1.
Right.
Which would mean that by the time the tortoise is covering the distance x, the hare already covered x plus y plus z, right? Which then gives us the ability to do x plus 2y plus z, and if you then make the x plus y move twice as fast as x plus 2y plus z, then we came to the conclusion that X should be the same as Z, right?
Right. I think that's the right approach. I think that's right. So basically, if x plus y plus z plus y
Correct.
will has to be equal to 2 times what here has or tortoise has moved, right?
Correct.
And if now you start solving the equation, that will boil down to x is equal to z, simple.
Correct.
And which will give indication like, so the tortoise has to move now equal distance what somebody will move from the head, and that will be the meeting point.
Correct. I think all of this is coming from the assumption that the hare is going to move twice as fast as tortoise.
Right. If you take 3 times or 4 times, then we have to equate it to the 4 times or 3 times. And again, it will be the same thing. Eventually, x will equal to z, whatever the picture you had drawn. So I think that makes more sense now. Yeah. Okay.
Right.
Yeah, I think the discussion helps. Okay.
Yeah.
Cool. So the next problem, if you want, I can go ahead. It's about the reordering.
Yep.
Okay. What is that? I'm just trying to open the problem and then share the screen. Share. Okay. Can you guys see my screen?
Yeah.
Yes, sir.
All right. So this problem is basically you are given the head of the singly linked list. The list can be represented as L0, L1, and so on, right? Whatever is a normal linked list. If you see example 1, 2, 3, 4. Now the objective is to reorder the list to be one of the following form. So which means it starts with first node, and then the next node is the last node, and again the next node is the second node, and again the next node is second last node. So basically you can think it like while we do palindrome, you match first and last pointer. So that's what you're doing, first and last. So you start with first, append the last, then you take the second element and the second last, and you match in the palindrome case, right? But here you have to take second element and you append the second last, right? So that gives us intuition here. It's same as the palindrome matching, but instead of matching, we have to append it to the list. But if you haven't done the problem of, let's say, palindrome, if you're just approaching it, it just means that somehow you have to take one node from the start, one node from the end, then again second node from the start, and then another node from the second last, right? So if you see the example 1, 2, 3, 4, so here of course first node is first, second node has to be the last node, because that's what they're saying in this expectation, what they have, how we want to reorder. So 1 and 4, and then second node, and after that it will be the second node, which is L1, which is node 2. So you see 2 over here, and then after 2 it will be the second last node, which is Ln minus 1, which is Ln minus 1 means second last node from the end, which is 3. So after 2 we have 3. So is the question clear? What we have to do, guys?
Yep.
Yeah.
Okay, let's see one more example if you like. So these were like even number of nodes. Let's see what happens if their number of nodes are odd, right? So 1 from the start, 1 from the next from the end, which is 1 and 5. Again, next node from the second node, and then second last, right? So 2 and 4. And then what remains is 3, and there is no third last because there are only 5 nodes. If there would have been 6, then it would have been a little different. Then it would have been 1, 6, 2, 5, 3, 4, right?
Right.
So, I mean, I know most of us were there in yesterday's session, and we did the problem of palindrome. So since we have done it, it's exactly on similar lines. If you want to solve, take a time to solve, we can solve, or if you want to just discuss it directly, there is very slight change. It's just a very minor variation of that.
Let's discuss it directly.
Okay. Okay. Is that okay, guys? Everyone?
Yep.
Yeah.
Okay.
Yeah.
Yeah, because we already did the yesterday's problem palindrome. It's very similar to that. So step one is definitely we have to find the mid of the linked list, right? Which can be done using slow and fast pointer or hare and tortoise, whatever you prefer to call it. In this case, definitely we cannot move the fast pointer with 3x or 4x. It was only the situation where, I mean, if you, only the situation when you're only trying to find there is a cycle, then you can move with whatever speed you can. But here, since you have to find the mid, it's very straightforward that you have to move the slope with 1x and fast with 2x. So step one is find the midpoint. And why we are finding the midpoint, why we need to find the midpoint, because that's the place where we need to stop, right? In the palindrome, even if you remember, you start from the beginning and last, and then second and second last. So that's what. So first step is we have to find the mid. Once we have find the mid, then it's easy. We just need to reverse the second half of the list. So when you reverse, so when you reverse, so I can just type and show. So it becomes 1, 2, 3, 4, right? So now you find the mid is 2, let's say 1, 2, because after 2, it will stop. So 2 will point to null, basically, after that, and you will have 3 and 4 will be the second list, right? So that this is step one. We have found the mid and we have divided into two different groups, right? First is 1 and 2, and second is 3 and 4. Now, step 2 is just to reverse it. So the list will change to 4 and 3. I mean, I'm pretty sure that's also very standard couple line code, right? To reverse a linked list or to find the mid of the linked list. So those are the standard subroutines. Now the crust is like when we have found, like we know the first half, which is, let's say this is L1. L1 is equal to this, and L2, which is already reversed, is this, right? Second half of the. Now the final step is just to take one at a time from L1 and L2 while they are not null. So if we take from list 1, it will be 1. Second element will be from list 2, which is 4. Again, we take another element. So and then after that, you move each of those lists. So that means L1 is equal to L1 dot next. And of course, L2, you move each of those pointer. I'm just writing some pseudocode. Once we have moved, then the next will be 2 and 3, right? So again, you pick the 2 and then which gives the 2, and then the second element from the list L2, which is nothing but 3, right? So this is the final output. And the way to choose between L1 and L2, I find it a little easier. Like, how do we choose while in the loop? I mean, of course, we'll choose while it's not null. Any of the list is not null, right? I just flip the pointers. Like one time I choose L1 and take the L1 because they both have progressed by one step, right? Now, this time I have chosen 1. Then next time I'll just flip it. I'll choose L2's element and put it in the resultant or the result linked list. And then again, next time I'll choose L1, I'll get 2 and flip it. So it will point to L2. And again, I'll get the next of L2, which is 3. So yeah, any questions or doubt? So this will be the final answer. So here we just have to append. And if you remember yesterday's, we were just comparing like, if L1, so it was like that. If L1 does not equal to L2, right? Which means if 1 was not equal to 4, that means it was not a palindrome, right? Remember?
Right.
Yeah, so that was, so we just, else you come out of the while loop and you just return true. I mean, here you return false. And if you went through whole while loop, you just return true, means everything matched. So step one is find the mid. Step two is reverse the second half. And before doing reversing the second half, of course, we have to separate L1 and L2. So once you have find the mid, you can say L1 dot next is equal to null, and whatever was the next will be L2, right? That's how you divide these two. Once we have these, then we just reverse in step two, we just reverse the L2. So 4, 3 becomes, sorry, 3, 3, 4 becomes 4, 3, right? And then we just go through each of the list one by one and append it to the result pointer, or maybe head, like head.next is equal to L1.next. Next time head.next is equal to L2.next. So only difference is in the step 3. Yeah,
Do you have code for this?
I do.
Like,
Yeah, I can share the code. Okay. So I think this is the code which I have. Let me show you the code and I can send you the screenshot if you want. Okay, so definitely first I take slow and fast. They all will be pointing to the head, right? And as I said, step one is to find the mid. So I keep on going until basically I loop for while fast as next, and fast next dot next, because it's moving twice. I plan to move it twice to find the midpoint, right? So I keep on iterating. Once I have found the midpoint, then I just say mid is equal to slow dot next, right? So that means it will be number 3, 4, right? And while I have done that, the slow is also at 2, right? So slow dot next is equal to none. So basically what I did 1, 2, and then I'm terminating it with a null. So that's what, once we have done these two, then I just reverse it. So basically what will go in the reverse? Basically mid will go, because mid is 3 and 4, right? So that's why I reverse it and I get the tail. So what is in tail? The tail will be 4 and 3, right? Because we have reversed 3 and 4, it becomes 4 and 3. Now I'm just merging head, which is 1 and 2, and the tail, which is 4 and 3, right? So when I come to the merge, definitely I have taken some dummy head, which is starting with 0, right? And I keep on going to the next, right? So which is, so let's say head is pointer 1 and tail is pointing to, tail is P3. So P3 is, remember, like 4, 3, and P1 was 1, 2. Now I keep taking next and I keep flipping over here. And of course, you have to also move the current. Once we have done, then it gives the result, which will be 1, 4, 2, 3. And reversing is again the standard algorithm. If you want, I can go through that also. Does this make sense?
yep.
Any questions, comments?
I mean, I've done it similarly, but is there any chance that the interviewer can ask us to try it in a recursive way, or?
I don't think so. Approach doesn't matter, like whether you
Right.
do iterative or recursive, as long as we are able to. But what is the exact question? What do
Yeah, I
you?
mean, I was just wondering, like, I usually think like the iterative way is more intuitive for me. Recursive makes sense in sense of trees and other structures, right? But then here, is there a possibility that the interviewer can ask us like to think of it in a recursive, solving in a recursive way?
I don't think so. I mean, I don't think so. As long as we are able to explain one, he should.
One
He will,
approach.
yeah. I think it will be very, very stupid if you say, okay, you gave me iterative, not do in a recursive way, right?
Yeah.
That will,
I think somebody said something somewhere around like
yeah,
if you ask if you do recursive, then you have to do iterative or vice versa. So I was just thinking like, does that even happen? Because I mean, your approach is more important than whether you're solving it in recursive or iterative, right? So that's what I was thinking too.
yeah.
What's the time complexity for this?
That's a great question. Let's see. So time complexity for this. So we have to go through all the nodes, right? Um, I think, see, for this one, while fast is it's see O of n by 2, right? Because we are only iterating half of the element, right? To find the mid, because fast is moving twice, so it's skipping it. So this is n by 2, and then after that we have reverse, right? Reverse will be of n. So of n plus O of n by 2,
But
and then
it will
merge.
be n by 2. Reverse will also be n by 2 since you are just
Reverse will
reversing.
also be n by 2, right? Right. And then merging is also n by 2 because you're only going half of 3 and 4 and 1 and 2, right? So that's
Mhm.
also n by 2. Since 2 is a constant, I believe it's O of n, right?
Mm, yeah.
Right, guys?
Yeah, I believe so.
Yeah.
But space complexity will be O of n as well because I'm taking a dummy and building whole current node and building whole new node, whole new linked list of n nodes, right? So space will be O of n. Yeah, because we are not rearranging, right? It says you may not modify. That's also given. See, you may not modify the values in the list node. Only nodes themselves may be changed.
Also, on line 33, do you want to return current dot next or do you want to return dummy head on
33.
33?
No, I want to return the current dot next. The reason, why? Because I'm already moving dummy, right? So dummy will keep on moving. So it will be 1, dummy will move to 1, it will move to 4, then it will move to 2, and then again it will point to 4. But current is not moving, right? So when you're returning, then it is at the head, which is head of the result, which is 1432, 1423. So we want to return current, not the dummy.
Okay.
Because if you return dummy, what happens? If you return the dummy head, then you're returning the end one, which is basically you're returning 3 in this example one. But we want to return the 1, right?
The
You
names
return.
are confusing, yeah, because we're calling it head and we're calling the other one current, but we are like
Yeah,
using
I
them.
agree. I agree. But I think logic is you have to return 1 from the start, right?
Right,
Yeah,
right.
I understand what you're saying. So it should have been current, dummy, current, or whatever. Maybe head should remain head. I think I used dummy head because I already had a head here, but that's why I didn't want to reuse the same name.
Yeah, cool.
But I think current should move and some different pointer, maybe like header 2 or whatever, Yeah. Any other questions? What, Gorika? Can you wait? Guys, anything else? Or do you want to move to the next question? I mean, any other question I can answer or we can discuss more. The more we discuss it, we just benefit.
No, I don't have anything.
Okay, cool. Okay. If nobody has anything else, then I don't know who's going to take the next question. What is it? Tapping or trapping the rainwater, right? I believe.
Yeah, it's trapped in the rainwater.
Trapping the rainwater, yeah.
Yeah,
Who
so
is Satish?
I was supposed to take, but I think he didn't join today.
Okay.
Is it okay if you put a stop now or?
Yeah, I also wanted to drop because it has been already past an hour. So
Yeah, sure, Aditya. One thing is like we will see if any other problems that we could add. I think we just
I
need.
can I can add the problems. Like I think I don't know. Last time I was talking to Sagar and I told him, give me one second. I was talking to him and I told him like about the list, but I didn't hear back from him. See, this is the list which I was talking about, but I didn't hear anything back from him. So we are doing arrays, right? So this is basically the most common questions, but I'm fine with any list, by the way. And the it is basically more on the pattern based, right? So this is blind 75 plus most common questions, and I have been asked like couple of questions, even variation of these from these only. So this list helps me anytime I want to brush up. I just practice these questions. So like two sums, and these are the array based question, and then string based, which is the most common, most like you'll 70 to 80% of the time, like you will get a question on the string. It's either it could be sliding window, anagram, palindrome, parentheses, or any other, right? And these I have categorized in the string. Of course, they also include two pointer, sliding window, merge interval, stack queue, all those specific, but I've just recategorized. And couple of DP problems linked with the string, but I have a different section for that. And then interval problems. This is what Sagar was talking yesterday, right?
Yeah.
So I have even a class for that itself. Insert interval, merge interval, non-overlapping, meeting room 1 and 2. So, and then heap problems, like these are very common problems. Kth largest, either it will be largest, kth largest, or kth smallest, or it will be frequent, right? So two categories I even saw in this lead code tutorial as well, which you can go later on. It's there in the link, you know.
Okay.
Yeah, you see the application or application of heap, right? You see either it will be top k or it will be kth. So top k is, you know, frequency, or it be the kth, like. So these are the two applications anyways. And then linked list, see, I have the exactly same question. Detect the cycle, what we did, reversing, reordering, palindrome, which we already did. And then these are some more tough questions. I was asked this in Facebook as well. Reversing list in K groups, merging, sorting, and then of course, LRU, heap map. Random pointer is also very interesting as well. And then these are the most common tree problems. Like if we do, like at least we'll have confidence. And then graph has, I have a bigger list, but I think these are the most common, like course schedule, number of islands. These I have not done, binary and matrix. Yeah. So I was just, I mean, I might put these in the Excel as well, but even the top list which we're doing, that is also equally good.
So
Okay.
this list, the one that you just shared, can you ping this as well in the group?
I did that multiple times, but for some reason, few folks were able to see and few were not. So it's some weird lead code bug, you know, which I don't understand. If you want, I can do it again, the group. But if you're not able to do that, I plan to put in an Excel sheet in the, maybe in the same Excel sheet, you know, which Sagar, we have in the description. You see this in the group in one of these. So today what I did, I pinned this Telegram channel and it has great material. I saw that it's there. Go to the pinned item of this. Okay. I can, and this is a sheet, right? So I can go to the same sheet. Okay. I can, this is the same Excel sheet, by the way, sorry. This one, I can put a tab and I can just say whatever, top frequent or blind, whatever. Okay. And I'll put it the same link. Sounds good, guys?
Yeah, sure. Okay.
Okay. And yeah, and this is already there. I found this is useful because a lot of people are, we don't want to buy or we don't want to, I mean, because we have plenty of material already. So this has got good list, and I did this in morning, the same thing. I have this list, see this system design. So I went through this. This is the pinned item. If you go to their pinned message, these are all the PDFs which they have, you know, DDIA. Even they have notes also for this data intensive, the same. I mean, a lot of resource, but again, since our time is limited and expensive, we need to focus exact specific things. We cannot do everything, right? And keep forgetting. Yeah. All right, guys, I'll stop sharing for now, and that's it from my end.
Sure. Thanks, Aditya. Thank
Sure.
you.
Thank you, guys.
Thank you.
Thank you.
Yep, bye.
Bye.